Okay, hi everybody. So we're going to have a look at some trig equations today and solving them. So I'm going to go through 4 examples. You've done all these kind before, but this should help you consolidate. So I'm going to do that one. I'm going to do that one. I'm going to do that one. And then I'm going to finish with that one. Okay, so there's a lot of sort of issues are going to crop up in this, a lot of things that you need to be aware of, and we'll just work through them. Hopefully they'll make sense. Obviously, if anything doesn't make sense, ask your teacher. Okay, so here we go. So let's just get started and dive into them. So I've got cos of 2x plus 30 equals 0.5. So because it's cos of a function of x, I am going to, sorry, that's gone a little bit blurry, hasn't it? So I'm going to use a variable instead of the 2x plus 30. So I'm going to use k. It seems to be the common one that's used. Cos of k equals 0.5. I need to rearrange this. So this is no longer x, this is k, but k is 2x plus 30. So 2 times 0 plus 30 is 30. 2 times 180 times plus 30 is 390. We go to our calculator and we graph. I'm graphing cos of x. I'm going to check I'm in degrees because that's what I'm after, which I am. I'm going to do my V window for the range of the k, because it's k that I'm solving for. Really important you do that exactly the numbers that are in there. I'll leave the y min and y max as -2, that's fine. And I get a nice looking graph. I do g solve and across an x calc, and I'm solving for cos of k equals 0.5. So I've got k equals 60. And I have got k equals 300. Okay, but that is not the x, that is actually k. So 2x plus 30 equals 60. So x is 50. 2x plus 30 equals 300. So I'm going to subtract, so that's 135. And those are the 2 solutions. Always a good idea at this point, just to be, you can be 100% sure that you've got these right. But if we go into our main mode on the calculator, and we type cos of 2 times 15 plus 30, so I've just substituted the 15 into there, I should get 0.5. And if I do cos of 2 times 135 plus 30, I should get 0.5. Just a nice little double check at the end. Okay, so that's the first one. Let's move on to the second one. So this time I've got a cos squared. So 11 cos squared minus 3 equals 0, between 0 and 360 degrees. So I need to rearrange this. So cos of x is equal to root of 3 over 11, or cos of x is equal to minus root of 3 over 11. The mistake that will be made here by a lot of students is missing the minus. So that's why we're doing this one. So I'm going to go to graph mode. I know I'm in degrees because I've just used it. And I'm going to draw the cos graph. There's no function of x this time, so it's just my V window is between 0 and 360. Happy with that. Oops, draw. And I'm going to do a g solve x calc, and I want the square root of 3 divided by 11. Okay, so I have over here x equals 58.5 degrees to its 1 decimal place, and I can go across, and I think that's a little bit blurry on yours, but it's 301.5 degrees. I then do the same thing, so I do a G-solve, and I type in minus root of 3 over 11. So I've got minus the square root. I'm going to put it in brackets, 3 divided by 11. And I get x equals 121.5 degrees, and cross x equals 238.5 degrees. All to 1 decimal place. Okay, so 4 solutions to that one. Maybe that one didn't look like it was going to have 4 solutions, but with experience you'll start to spot that sort of thing. Okay, next one. So this time I've got 3 sine squared x equals 1 minus cos of x. So I've got sine and I've got cos. The sine is squared. It's going to give me a slight problem here. So what I'm going to do is I'm going to use my sine squared x plus cos squared x equals 1 to change this into a function of cos of x. So that is going to be 3. So sine squared of x is 1 minus cos squared of x. As ever, we're just going to take it nice and steady so that we don't make a mistake. Don't try and do too many things at once. That's where things go wrong. So I've now got a quadratic in cos of x. So I'm going to use a letter to replace that just to make it more manageable. We like to do that. So I've got 3y squared minus y minus 2 equals 0. I'm going to solve that using my polynomial function. And I have y equals 1 and y equals minus 2 over 3. Okay, so we're nearly there. So obviously y is cos of x, so cos of x equals 1. So I'm going to draw my cos of x is between 0 and 360. I think that's already set to that, 0 to 360. And I'm going to do a G-solve based on 1. I think really probably something that we wouldn't have needed to do. We know this answer, we know what's going to be. $360. Okay. And then we need to do the G-solve again on minus 2 divided by 3, minus 2/3. So got cos of x equals minus 2/3. So that gives me x equals 131.8. And 228.2 degrees to 1 decimal place. Okay, so 4 solutions to that one. So that one was using the trig identity of sine squared plus cos squared equals 1 to get my quadratic all into a function of one of the trig ratios. Okay, so the last one. So now I've got tan of x equals 3 cos of x. So again, I've got two different trig ratios. It would be nice if they were in the same one. So this time I'm going to use tan of x equals sine of x over cos of x to give me 5 sine of x over cos of x equals 3 cos x. I'm going to multiply through by my cos of x to give me 5 sine of x equals 3 cos squared of x. So can we see now we're in a similar situation we were on the previous example. So I'm going to use my other trig identity to replace the cos squared of x with 1 minus sine squared of x. So I've got 5 sine of x equals 3 times 1 minus sine squared of x. I'm going to multiply out the brackets. I'm going to collect them all to one side with the coefficient of sine squared of x positive. So I've got 3 sine squared of x plus 5 sine of x minus 3 equals 0. So I've now got a quadratic in sine of x. So I'm going to set y equals sine of x. So I've got 3 y squared plus 5y minus 3 equals 0. So y equals, just running out of space. It's a polynomial function. I'm going to solve that quadratic. Okay, so we've got 4 decimal. I'll go to 4 decimal places. 6, 8, 3. Oops, sorry. Okay, so I've got sine of x equals 0.4683. I've got sine of x equals minus 2.135. Can we see this one's not going to give us any solutions because sine of x only goes between 0 and 1. So we need to explicitly write no solutions there. Always state it, they must be clearly rejected. So x equals, so we're now going to do the sine graph to finish that off. And I'm between 0 and 360. So my GSOL, let's count. So I've got x is 27.9 across and 152.1 degrees to 1 decimal place. So 2 solutions to that one. So actually that was quite an interesting question because both trig identities came into play on that one. Okay, so I hope that was all clear. You're going to have some examples to go through in a second. Okay, thanks very much. Bye.